The Effect of pH on Enzymes by Darlene Wolosky and Ashish Murthy. Our hypothesis. The tube with a pH of 7 will have the greatest reaction occur, and thus the darkest brown color. Procedure. Label 7 test tubes, 1 through 7, pipette 1 milliliter of potato extract and 2 milliliters of the buffer into the respective tubes. Place the test tubes into the water bath for 10 minutes at 37 degrees Celsius. Wait 5 minutes to allow the pH buffer to affect the enzyme, if it will at all, and add 1 milliliter of catechol into each tube. And then you record your results. And here we have a chart saying which pH buffer is going to be in which tube. In tube 1, we're going to have a pH buffer of 2. In tube 2, we're going to have a pH buffer of 4, 3, pH buffer of 6, 4, buffer of 7, 5, buffer of 8, 6, buffer of 10, and 7, buffer of 12. Results and conclusions. Here's our chart illustrating our tube buffer and our results. And our results are based on a scale of 0 to 3, 0 being no color change, 3 being dark color change. In tube 1 we had no color change. Tube 2 we had no color change. 3 we had dark color change. 4 we had dark color change. 5 we had more color change, then more color change, and then lastly we only had a little color change. Our results and conclusions. Tube 1 we had no color change, as you can see in the picture. There's really no brown that showed up here, so that's a 0 on a scale of 1 to 3. And our conclusion was that a pH of 2 denatures the enzyme to the point where it is completely unable to function, explaining how no function occurred when buffered with a pH of 2. For tube 2, there was another no color change. It's 0 on a scale of 1 to 3. Here you can't see any brown. Our conclusion was that a pH of 4 denatures the enzyme to the point where it is completely unable to function, just like with a pH of 2. The enzymes are denatured by the acidity and can no longer function and carry out their reaction, meaning there's going to be no brown that shows up in the tube. Results, tube 3, there's a dark color change, 3. And our conclusion that a pH of 6 is optimal for the enzyme to function since it was the darkest. You can see here all the brown that showed up in tube 3. In tube 4 there was a dark color change, another 3, and our conclusion was that a pH of 7 is nearly optimal for the enzyme to function. Not completely optimal, because as you can see it's not as brown as the other picture, but it's still a 3 on a scale of 0 to 3, so it's still a pretty good turnout for the enzyme. Tube 5, more color change. So that was a 2 on a scale of 0 to 3. Our conclusion was that a pH of 8 is not optimal, but still allows a reaction to take place effectively. So you can still see the brown. There's still an obvious difference here. There was obviously a reaction carried out, but it wasn't as dark as the pH of 6. So you know that it's not functioning at its optimal level. Tube 6, more color change. Another 2 on a scale of 0 to 3. Our conclusion was that a pH of 10 is not optimal, but still allows for reaction to take place effectively. So again, not as effective as a pH buffer of 6, but it still carries out its function anyway. So, tube 7, little color change. And that's a 1 on a scale of 0 to 3. So you can see here that there's a little bit of brown. It's not exactly like there was no reaction, but it's definitely not as strong as the other ones we've seen. Our conclusion was that a pH of 12 denatures the enzyme to the point where it is nearly unable to function. So some of it's still able to function, but there was definitely some denaturing going on. It's definitely not functioning at its optimum potential. And here is a graph that illustrates what we've learned from our experiment. Down here in tube 1 and 2, so a pH of 2 and a pH of 4, nothing's really happening. It's been denatured so much that no reaction could take place. There was no brown that showed up. And then you go up to here in test tubes 3 and 4 where you had a pH of 6 and 7, and you can see that it worked pretty high up there. It had the largest reactions. That's where it works best. And then you see it move down a little bit to 2. It's still functioning, but not quite at its optimal level for pHs 8 and 10. And then at a pH of 12, there's very little function that's happening. reaction taken out. So you can see here that there's nothing, but then it goes up, so this is where it's working best, and then slowly it starts to decline a little bit. So that's the general trend with the pH and how it affects catechol oxidase.